Okay, in this video, we're going to be talking about the earliest start time. And if you would like to follow along in our book, or if you'd like to work through more examples, it's going to be on page 157 to 158. The earliest start time, just putting it very simply, is finding or what is the earliest time that an activity can begin. Okay, so let's go ahead and get started with this example here. We've already worked with these type of graphs before. Remember that these graphs are showing us or displaying the information of when a project can start and when it can finish, and it has all the little projects, all the little tasks built into it, okay? So let's figure out the earliest start time. Notice that the start is when you will start, obviously, and notice this arrow here. This arrow tells us how long it takes to do start. So when we're trying to figure out at what time can we actually can A start, really it starts at 0. Okay, that's I would probably say the most tricky is being able to figure out when A can start. From there, everything else builds on. So like if A starts at the 0 minute mark, and if it takes 1 minute to do task A, that means B will start at minute 1, because the time from 0 to 1, A is conducting its task. And from here, you start building on. If B takes 1 minute, or I'm sorry, if B starts on the 1 minute mark and it takes 1 minute to do it, at what time does C start? Well, that'll be at 2. Okay. And then if C starts at 2, and if it takes 3 minutes to do task C, then basically you're adding again to where D can start at 5. Let's just go down to E, just at random. If B starts at the 1 minute mark and it takes 1 minute to do task B, E can now start at the 2 minute mark. Now, if you notice, based upon this information, C and D, or I'm sorry, C and E have the same time. So what does that tell us? Well, it tells us that these two tasks are going on simultaneously. Okay. Now, everything is pretty simple up to this point, and I'm going to highlight G for a second. What makes G special is that now there are two arrows coming into G. Well, if D starts at the 5 minute mark, it takes 2 minutes to do task D, then that means G would start at 7. But let's look at E for a second. If E starts at the 2 minute mark, and if it takes 1 minute to do task E, then technically G could start at the 3 minute mark. So which is it going to be? Is it going to be the 7 or the 3? Well, let me use this example that I used in class. Let's say if this was me, okay, and I was running to my car, and for some reason it's a futuristic rocket car, okay? So if it took me 60 seconds to get to my car, but my friend here's my friend, it took him 90 seconds. Let's just say he tripped or something. So it took him 90 seconds, okay? At what time would the car actually start? Well, here's the problem. My friend has the car keys. So even though I would get there soon, or even though I would get there quicker, the car isn't going to be cranked until we hit the 90-second mark. Okay. So in other words, the slowest person, that's what time we're going to use. So using that example, going back up to G here, notice that E would get to G in 3 minutes, but D would get to G in 7 minutes. So unfortunately, E is going to get to G a lot faster than D is, but he's just going to be waiting around. And so G will not officially get to start until the 7 minute mark. Okay, so in other words, whenever you have multiple arrows going into one vertex, it's always going to be the slowest time. All right, let's look at F. Notice we have two arrows going into F. D can get to F at the 7 minute mark. E can get to F at the 3 minute mark. Well, 7's going to win. So notice once again, G and F has the exact same EST, or earliest start time, which means they're going on simultaneously. Let's look at H. G can get to H in 12 minutes. F can get to H in 9 minutes. So who are we going to take? Well, we're going to take the largest one, which is 12. And then lastly, if H starts at 12-minute mark, that's the 3 minutes. So that means the finish is 15. And what this would be called is the minimal project time. So let's do another example. Okay, here's our next example. We have another example here, start to finish, and we have all the different tasks that we have to do. So let's go ahead and do the EST. All right. So notice here that the start, once again, has a 0 for its arrow. So that means A and B will be starting at the 0-minute mark. Okay. So then we start building. So let's just look at C here. Okay. Since it's the closest to B. If you notice C, let's say if B starts at the 0-minute mark, C would then start at the 2-minute mark because of the fact it takes 2 minutes to do task C. Well, let's look at E here. Now, of course, you might be wondering, Coach Ford, how are you doing all this, or what is there a set way to kind of to start doing your ESTs? And the answer would be just kind of look at the way your arrows are. Okay. The reason I didn't go to D is because I had 2 arrows pointing at D, and I just kind of wanted to knock out the easiest and from there. So let's look at E for a second. So B starts at the 0-minute mark, B starts at 2, and then E will also start at 2. All right, now let's look at D. Notice D has 2 arrows, okay? A starts at the 0-minute mark, and then it takes 1 minute to do task A, so technically it would get there at 1 minute. But if you notice that C starts at the 2-minute mark, there's 3 minutes to do task C, which would get you there at 5. So which one are we going to take, 1 or the 5? The answer is we're going to take the 5 because we take the slowest time. All right, let's look at F. Now notice F now has 3 arrows coming together. Well, if D starts at 5, it takes 4 minutes to do task D. That would be 9. Well, let's see, if C starts at 2, it takes 5 minutes, or it takes 3 minutes to do task C, then that means it will be 5. And I'm just writing my options right next to F. And then if E starts at 2, it takes 5 minutes, that would be 7. So we have 9, 5, and 7, which is going to be, it's going to be the largest one, which is 9. And then lastly, 9 to 7 gives us a total or minimum project time of 16 minutes. So it would take 16 minutes from start to finish. Let's do one more and then we'll be done. And here's our next problem. Now, let me encourage you at this point in time, if you ever want to stop and go ahead and work through these examples before I finish them and just pause the video, please feel free to do that, okay? Let's go and get started. Start to A, though at this point in time, hopefully you know it's going to be 0, okay? All right, so B, D, and C, they'll be 1 each. 1, 1, 1, okay? All right, moving on. Now remember, 3 actually has 3 arrows, so that means there's going to be 3 times that we're going to have to look at. B starts at the 1 minute mark. It takes 2 minutes. That is a possible of 3. D takes 1 minute, takes 3 minutes for a total of 4. C is 1 minute, takes 4 minutes to do task C, or 5. Which one are we going to take? 3, 4, and 5? The answer will be 5 because it's the largest one. We always take the largest one. Now let's look at F. If E starts at the 5-minute mark, it takes 5 minutes to do task E. The answer is 10. Now notice for the finish, we have 2 arrows coming into the finish. So F starts at 10-minute mark. It takes 7 minutes for a grand total of 17. Or E starts at 5 minutes to 5. That gives us 10. Which one are we going to take, 7 or 10? We're always going to take the largest one. So 17 is your minimum project time, and those are all your ESTs. Remember, whenever you have multiple arrows going into a vertex, it's always going to be the largest, or I'm sorry, the biggest number. All right, if you have any questions, please let me know.